So frankly speaking, whether it's internet or IT, you can see as the time has progressed, the prices has actually gone down. Whether you talk of telephone, services, your mobile phone services, or your internet, or your cable, or your IT products, right from software to your all these mobile phones, laptop, desktop. So generally, I think the economists kind of ignore how what kind of model runs when I mean, like you can see Samsung year by year, or Intel year by year. The professionals there, they're investing more and more into R&D. The prices of materials, as in like the ones which they use in their manufacturing, or setting up the fabs, or the other kind of precious metals, including gold and silver that they have within their chips, that is increasing. The I mean, like as far as manpower is concerned, that is also increasing. What people were earning, say a decade back, a couple of decades back, that is also increasing. But invariably, if you see, mobile price has been going is saturated or going down. So that basically means they are getting deflated. Including your internet services. I think India is having uh, one of the lowest in the world. So there are few models. I do not know. I mean, like I'm not being an economist, but this one can actually observe. So what economic models? I think this is where you can go and take courses on the microeconomics or macroeconomics and stuff like that to understand why does it happen in particular sectors and not in other sectors, even when everything is going up. Engineers, say Samsung, Intel, Apple, Motorola, they are all, but the price is almost constant. When you talk of any other thing, you say, oh, inflation is going up, it's 6%, it's 8%, it's
So
4%.
Moore's law is kind of the heart of all of this, like why the prices are going down. Is that so?
What? No, I do not know. I do not know. I only know that this is what has happened. You just compare the price of the internet facility, or even mobile phones services by the same Airtel, or any company you take. Uh, 20 years, I mean, like 2 decades back, a decade back, and now. Similarly for your mobile phones. Similarly for so many other things. Your desktop computer, your laptop computer, your palm top, even your smartphones. I mean, you, what is? Nobody talks about this. And one thing I know for sure, as time is progressing, more and more investment is into R&D. I think probably Samsung would be having more patents and more investment in R&D. IBM is having the same. Apple is having the same. So this you can actually, it's there on the net. You can just pull out the data. So I generally start the class when it's around 30, and also right now I can only see 20 students. Any questions? Yeah, and I keep asking you to kind of brush up your past knowledge and try to get involved in things, because yeah, these are like your courses from which, and as far as EC is concerned, they have a lot of opportunities in terms of VLSI. It's a huge domain and there's a lot of requirement. And also, I mean, like if you do a couple of courses on, so you guys have certain advantage that you can set both for computer science. You just need to do data structures and algorithm as your major prime course, and a lot of VLSI. So you can sit for Googles and LSIs and Intels and Samsungs of the world. So you can sit for both kind of yeah. I mean, like in near future. So it's going to be helpful. So as far as yeah, even signal processing, TI Texas Instrument is like making the chips. If, have you how many of you heard about TI?
But I've heard about the
Okay, yeah.
There's
So
apparently some annual competition of some sort they hold that's open for all. That's how I heard about them.
yeah, so they make the processors for your signal processing. You need it at so many places, and I think ultimately everything boils down to chip. So even right now, of lately, I have some friends, relatives, and even students who are working for different, and especially colleagues also, all around the world. So right now, NVIDIA was another. So that was a graphic processor. I mean, like since we are talking about processors, signal processing also uses the processor. So TI is one of the companies which is doing that in a big way. And they have foundries, or they have the manufacturing plants in Texas, and they do all kind of designing and stuff like that. Similarly, for graphics, I mean, like all the displays that you're seeing, that is actually using all these. So NVIDIA is the numero, in that, and you must have heard about ARM. So NVIDIA of lately kind of ARM is again a processor. NVIDIA is also making a processor for your graphics. ARM is making it for your mobile phones. So they all have different approaches or architecture or some design different from each other. And so I think lately somebody did mention about. So I'm just talking about processors in general and stuff like that. So that was taken over. So this takeover keeps happening, but the requirement never goes down. It just boomerangs. So NVIDIA was specifically for your graphics, and ARM was specifically for your mobile phones and stuff like that. And somebody did ask me a question. Like initially, I said only after you go through, you would see why why you need to have different processor. So it's the basic reason is like for different application your requirements becomes different. That's why you need different processor. So when I talked about in terms of power requirements, it has got to do with so when you're carrying mobile, you would not you cannot log to 220 I mean like 15 volt or 24 volts or even higher voltage of operation. So what you would want is minimum power. So that is what. And in the future, what they are trying to do is I still see 24 students. I mean, like, are they not aware or they're still coming back? I'm just talking just to make So should we start the class? I think at least the enrollment is around 38
38. Yes, sir.
Yeah. So this is going towards 60 to 75. Why? What's wrong with the rest? And then they asked me to send you the slides and stuff like that. Oh, what happened? All of a sudden, from 25 it became 22. Some network issue or what? Yeah, Manasa, just ask them to come ASAP.
Yes, sir. I dropped a text in the group.
So it becomes 25. I can start. I thought it's going to be 30 very soon. Why are you taking time? Anyways, so the whole goal is like to get you equipped and A lot of people join all these big tech companies just after they graduate, all across from IITs, triple IITs, NITs, and I think some of you already know that they have this VLSI. The MIT is basically running some SMPP program where BTech, MTechs, and PhDs are working in processors, in terms of design, in terms of manufacturing, so on and so forth. So IC design is also IC design can be application specific, like what we call as ASICs. Embedded is also more or less the same. There, the hardware is already designed, and you use the gates in that hardware for your own particular application. So there, it's bigger. The disadvantage is you can use any way you want, but it has a lot of limitations, including it's bigger in size, and it doesn't use the most optimum resources. So it's generally used for some applications, but like you would never use an embedded kind of system for a very application specific purpose. So there you use ASICs, application specific integrated circuits, which is kind of tailored made for your own specific application, so that the cost goes down, um, the size goes down, and so on and so forth. And it is very specific, like a chip which you use, say, in an elevator. That chip has only very limited functions, and its requirement for these type of processors is very limited. So that's application specific chip. So there you may use that should be smaller. And similarly, like if you're entering a metro station, so if you imagine about chip, it's almost everywhere, from your automobile engines to your lifts to your entry ports of all kind of metro station, exit port of all kind of metro station. It's there everywhere. So now it's 25, so let's start. I think let's get back to the 8085 instruction. We already talked about this. So these instructions can be grouped into 5 different groups. The first one is your data transfer operation. The second one being the arithmetic operations. Third one is your logical operation. Fourth one is your branching operation. And the fifth one is your machine control operations. Okay, so this is actually the onset of your assembly language programming. Okay, so we had talked about this being bifurcated into 2. One part we call as the opcode. Essentially, that means it's the operation code, and the one on which this opcode operates upon is the data. So the data is what you called as the operand. Okay. So let's start with the first one, the data transfer operation. So these operation copies the data from the source to your destination. So please note down all these data transfer operations. The first one is move, M-O-V. Class, are you there? Oh, can you see this? No, sorry. Oh, you didn't. Sorry. You should have told me. I didn't. Yeah. So I wasn't sharing this. Can you see this now? Hello?
Yes, sir.
Can you see this?
Yes, sir.
Is some audio problem? I cannot hear you guys.
Yes, sir. Yes, sir.
Yes. Good. Better. That was audible. Okay, so please note down. So first, let's start with the first one, which is data transfer operation. So this operation copies the data from source to your destination. So source can be a programmer, source can be any part of your memory or any peripheral devices, and the destination most likely is,
Excuse me, sir.
yeah.
Sir, only your present screen is visible. We couldn't see any PPT or something. I think you did not share the entire screen.
Just hold on. Okay. Yeah, that's why I asked you. Just a moment. Can you see now?
Yes, sir.
Yes, sir.
Is this screen visible to all?
Yes, sir.
Yes, sir.
Yes, sir.
All right, all right. So let's start with this again. So the first one is, I think, let me go 2 slides before. We talked about all these five. The first type of instruction was your data transfer operation, then the arithmetic operation, logic operations, branch operations, and the machine control operations. So we have talked about this last time, and we also talked in terms of your opcode and your operand. Now let's start with the very first one, the data transfer operation. So these operations copies the data from your source to your destination. So the source can be anything. The source can be you as a programmer from any kind of RAM memory or from the registers within your CPU. And the destination most likely is going to be either any of them, including your accumulator, where all kind of arithmetic and logical operation occurs. So please note down the various types of instructions that you write in your assembly language program. It's move, MOV move, MVI move immediate, LDA is load into the accumulator, and STA is stored from the accumulator. So the transfer of data can happen between the registers. So remember, when we are talking about this, try to retain your previous knowledge, especially in terms of the programming model. First of all of you just try to relate to this one. This is your programming model, where you had of your 8085 microprocessor architecture. So it has a pin diagram, it is an architecture, we have talked in detail about that, and then we have also talked about its equivalent programming model. Okay, so in the programming model you have accumulator of 8-bit, flags of 8 bits where only 5 bits are relevant. Then you have registers B 8-bit, C 8-bit, D 8-bit, E 8-bit, and H and L also 8-bit. Then you have program counter and your stack pointer. This also we have talked about. These are of 16-bit each, and this helps you to point the particular address in the external RAM. The data is transferred only in form of 8 bits at a time, while address is bifurcated into two, lower hard and lower order and higher order of your address. So this is one thing which you need to kind of retain to understand and program your various types of instructions. Just a moment, sorry. Yeah. So the data transfer happens between the registers. That means between, say, B or C or D or E, or between, say, between A and C. So A is basically your accumulator. Data byte is 8 bits, right? To a register or a memory location. So memory location is what we are talking about, external RAM memory. And that RAM memory we have already studied and talked in detail. So each location has an 8-bit storage place and can be identified by a 16-bit address. The transfer of data can happen between your memory location and a register, and between the input-output devices and the accumulator. Okay. So when the data is being transferred between, say, one register to another register, you use the MOV instruction. MOV instruction. Like, we will just take examples to enhance the understanding of this statement. Am I audible and the screen there is, if you...
Yes, sir.
Yeah, at least some
Yes,
of
sir.
you, or at least one of you. Yeah, Ishan. Yeah, they're already 27 now. Yes, people will start. So that seems more or less fine. So yeah, if you don't get it, just tell me. Then the second type is between the register and the memory location. So memory location can be an external RAM having, say, a memory address of, say, 4042. So 4042 is a 18-bit address, right? So 4042, let's say it's in hexadecimal. Okay, what is this equivalent binary form? All of you? Hello? I'm sorry, I mean, like, this way to communicate is kind of... So let's take an example of 4042 or 4004. What is its binary form? Sanya? Man?
सर 400 सर 4004 का 1 सर 5 times 1 then 0 1 00 1 00
ये कितने बिट हो गया भाई? 5 times 0.
सर 369 सर 12 bits सर 4004 का 12 bits होगा
एड्रेस का भी 12 बिट होता है?
नो सर 16
So before you say, you should try to cross verify. Manali. Or let's take in a very simple example. Say 4,000,
Yes, sir.
3,000, or 2,000.
Yes, sir.
Can you tell me the equivalent binary form of this address? So this representation, like 2000, 4000, these are like addresses, 16-bit addresses. So what is its equivalent binary form? Like what would the machine understand? We are talking
Sub
in
sub
terms
four
of the
sub 4004 address of 4004.
address name, its equivalence. I'm not talking about the address. That it's we have already we have just taken an example as like 4004 is like from where we want to say transfer the data. So 4004 has a 8-bit data, say like 2C or 1A. So all I'm talking is whenever I'm talking like 2C or 1A, it is in the hexadecimal form. Now what is its equivalent binary form? That is what I'm asking you.
Yes, sir. So binary form of 4004 is uh, sir 5 time of ones and 01 and 00100.
Come with this again. Arvind, any volunteers? Dhiren,
Sir, we will put 0 before the number I have converted, like 000.
can
Then
you complete it? Okay, one at a time. Sanya,
yes, sir.
can you give the
Sir,
complete?
so the address is of 16 bits, so we'll add zeros before the
So
number.
tell me, you don't need to tell me. You tell me what is
Okay.
included. Simple question, straight. It is one-liner answer. Ishan, Ishan, not available. Ishan is not there. Next, Dhirendra, you also not there?
Sir, I'm here, sir.
Okay. So please answer me. Banot, Banot,
Four. Hello, sir.
Banot. Anil, Anil. So you guys are online and still not there. Anil,
Yes, sir, I'm here.
okay, you are there. So what was my question? Anil, what was my question? What happened? Daksh,
यस सर 4004 का इक्विवेलेंट बाइनरी रिप्रेजेंटेशन करना था
सही
सर स्पीकिंग फ्रॉम सर मैं राइट से लेफ्ट में जा रहा हूँ मैंने
हाँ, हाँ।
डाल दिया 001 001 0 5 times 1 and then for the rest 16 bit एड्रेस पूरा करने के लिए 0 लगा देंगे
Okay. So this is like representing that address. In that there will be an 8-bit number. Okay. So if you want to move that 8-bit say into register B or register C, or if you want to exchange between B, C, D, E, H and L, you will use statements like MOV. If you want as an external you're keying in, you're a programmer, you just want to key in 8-bit into your accumulator, where you perform all kind of arithmetic and logical operation. You use statements like MVI, so which is move immediate. Then you have LDA, that would be loading into the accumulator immediate, loading into your accumulator. And when you talk about STA, it is moving out from your accumulator. Suppose you have the result into say 4004 memory address. You want to store the result into 4004 or 4005. Obviously, you would never like to overwrite on the previous location. So suppose you have 1A in 4004 and 1B in 4005 memory address space, and you want to add these numbers. So you perform the addition in your accumulator. Once the result is there, then you would like to store it some other place, say 4007 or 4008, so that you do not overwrite on your previous data, right? So there you will use your STA command. So the data transfer happens between your register like B or C. So you can move from register B to C or B to E, B to D, and so on. Then between your registers and your memory location. So like from 4004 memory location into your register B or register C. Then between memory location and your register. So this is vice versa of the previous one. And between the input output devices. So they can be there. You can just, as a programmer, feed in the data afresh into your accumulator. Input output devices can be your keyboard. Is that fine? Ishan,
Yes,
are you
sir.
back? Ishan, are you back? Still not around. Okay. He was there in the beginning. Maybe. Then the next one is your LXI instruction. Please note down this. This is very important, essentially because it is talking about the 16-bit data. 16-bit data. So the 8085 provides an The additional logical operations. So this again would help in all types of various operations that you carry out in your accumulator. So it rotates the contents of your accumulator one position to either left hand side or the right hand side. Please note down, these are very important and very critical. RLC, which is rotate the accumulator left. So generally the 8-bit number, the right hand side most is your 0-bit and the left hand side is your 7th bit. So it is 0, 1, 2, 3, 4, 5, 6, 7. So zeros is your first bit and bit 7 is your bit 0 is your lower order bit and bit 7 is your higher order bit. So bit 7 goes to bit 0 and the carry flag is activated. Similarly for all the other instructions, including RAL, rotate the accumulator left through the carry. So in this, the bit 7 does not go to bit 0 but goes to your carry, and the carry in your flag goes to bit 0. Then you have RRC, which is rotate the accumulator right, and RAR, which is rotate the accumulator right through the carry. In this, basically bit 0 goes to the carry. So which bit represents carry in your flag register class? Dhiren? Okay, this Sai Sudhir. Sai Sudhir, you there? Yeah. Can you go back to your 8-bit flag register and let us know which bit represents the carry? There are two types of carry. One is auxiliary carry and one is carry. So which bit represents that? The status of that bit will be getting affected when you are using these types of instructions. So which one is that bit? Sai Sudhir? Sudhir? Yeah, tell me. We have talked about this last time. So have you not noted down which one is carry? See, you every time when I'm talking about something, if you do not pay attention, you will be. Now, can you identify which one is for carry? Sudhir. Yeah. Can you see the screen? हाँ बोलो, देख के बताओ और अपने नोटबुक में please write it down. So are we talking about auxiliary carry or are we talking about carry? Now, can you be louder? It's always important to remember or at least have some basic knowledge, or you need to brush up whatever has been done before. Otherwise, you will be completely lost in the class. First of all, the blackboard thing is missing, and secondly, until unless you know your previous knowledge, this is a build-up of that. No, I say this, then you cannot relate without having at least basics of your previous knowledge. That's how you will build up. So all of you, please note down this. And I will go to the next slide, and then I think I will finish with today's class. Have you finished, all of you? No answer.
Yes, sir.
Yes, sir.
Finished? Okay, then I go to the, I think this is the probably last slide for today. So RLC and RAL, so between RLC, RAL and RRC and RAR can be further understood by this. So here we said that this is not only going to the bits, bit 7 is not only going to this, but the carry flag in the flag register. While in the RAL case, bit 7 is going into the carry flag, and the value of the carry flag is then overwriting into the lowest order in your accumulator.
Sir,
Yes,
sir, I
yes.
have a doubt. Sir, in this, why we are sending the seventh data to carry as well as zero in
Yeah,
rotating?
these are used in different arithmetic operations that we will be doing later, so you will have better. There are operations where this is required.
Okay, sir.
I think I will only, so yeah, I think so. Between RAR and RRC and RLC and RAL is but better understood when you talk of this, right? So is this clear? Again,
Yes, sir.
rotation, which comes under the logical operations. This you will be this you may use for different types of operation, as we will be, start asking you to program something which is, of higher order. You will see its usage. You will see and appreciate its usage. Remember, in machine language, they are only talking about zeros and ones.
Yes, sir.
So yeah, I think it's almost time. We will be starting with other types of logical operations like compare, immediate, so on and so forth in our next class. And again, when we are talking about this Z, CY, S, so when we are using these commands, the results get stored in your accumulator, and its updated version after performing this various type of operation is stored in your flag register. So those flag registers like 0, carry, auxiliary carry, sign comes into play. So your effective answer is not only in your accumulator, but also in your flag register, which is in which only 5 bits are of importance. What are those 5 bits? Before I end, what are those 5 bits?
Carry, auxiliary carry,
Sign,
parity, sign,
and 0.
yes, and 0.
Yes, anybody else?
And also there is a parity flag.
I think she mentioned about parity, right?
Yes, sir.
Parity flag, carry flag.
0, auxiliary, and sign.
Yeah, if there's somebody who's behind you, I think I'm also getting a lot of disturbance. So yeah, one by one you can say. So so the overall results is not only reflected by your 8-bit accumulator register, but also the values within your flag register. So when you perform all types of arithmetic or logical or any other types of operation, you have result in your accumulator, but you also have updates in your flag register. Is that clear?
Yes, sir.
Anali, you there? She's not
Yes,
there.
sir.
You're there. All right, so let's meet. So that's all for today. We see you on Friday. And I think the moment I start giving you assignments, things will be more interesting, because once you start to do, simple addition, subtraction, all kind of arithmetic and logical operation using this assembly language, you will be able to appreciate it more. So assignments would just help you to understand better. And then I think the lab sessions, if it is not there, if the university is not open, you can download. I will tell you the links from where you can download the simulator, and then you will have far better understanding, and so on. So thank you. Any questions before I leave? Sanya, you were saying something.
Sir, thank you, sir. I was just saying thank you.
Okay. Any questions? If not, then I make a move.
Good afternoon, sir.
Okay, thank you. Thank you.
Thank you, sir.